All right, we're going to look at one other type of question that we probably didn't run into in class, but it is similar to the U substitution and the factoring problems that we were practicing this last week. We can see that this one is in U substitution. We notice the 6 is twice as big as the 3, so that is a U substitution problem. We can go ahead and try to factor it. Factors of 1 or 1 and 1. And they're not going to add up to 5. So we cannot factor this one. So we have two options. We can complete the square, or we can use the quadratic formula. Now the quadratic formula really works for just quadratics, but we can kind of trick this into being a quadratic. So this is going to be our x, and this is going to be our x squared. So our a is going to be 1, our b is going to be -5, and our c is going to be 1 when we use the quadratic formula. Okay. So instead of writing x, we're going to write x cubed. Okay, so x cubed is equal to -5 plus or minus the square root of -5 squared minus 4 times 1 times 1 all over 2 times 1. All right, so that's going to be equal to 5 plus or minus the square root of 25 minus 4 all over 2. I'm sorry, I can't multiply, so that should be a 2, excuse me. Should be a 2. Okay, so 5 plus or minus the square root of 21 all over, not 4, 2. Okay, so now we're going to write our x cubed is equal to 5 plus or minus the square root of 21 all over 2. To undo the cube, we're going to take the cube root of both sides. Okay, so x is going to be equal to the cube root of 5 plus or minus 21 under the square root divided by 2. So 21 under the square root and divided by 2. So this is kind of a mess. There is where you can rationalize the denominator with a cube root, but we don't really want to get into this. This is probably a little bit uglier than seeing things you'll see in your book or on the My Math Lab. But this can certainly be done. And then to write your two answers, you just write one with a plus and one with the minus. So it is a mess. We can also do this one with U substitution. So we're going to let u equal the smaller exponent, which is x cubed. So then when we take your square, when we have exponent raised to an exponent, we multiply, so that's going to give us x to the 6th. So this becomes u squared minus 5u plus 1. And then we get to play with the quadratic formula. So it's going to be very similar. U is equal to -5 plus or minus square root of -5 squared minus 4 times 1 times 1 all over 2 times 1. So we'll go ahead and work all of that out, very similar to what we did last time. Okay. All right, and then we'll go ahead and replace u with x cubed. And now we're arriving at the same place where we did not do the u substitution. So again, you don't have to do the u substitution. I know a lot of folks didn't particularly like it in class, and I understand it's kind of weird, but this one I would argue might be a little bit easier to do as a u substitution, but it's certainly possible to do it without the u substitution. The u substitution really helps us realize that it's in quote-unquote quadratic form.